Now, right away, I'm gonna find how would say? I'm gonna complete the square. So complete the square is gonna be 2 minus 4x. Okay, let me start with the negative x square and then minus x square and then plus 2. And now I take a negative out and this is gonna be x squared plus 4x space and then 2. Okay, this is gonna be plus. Okay, take this divided by 2 is equal to 2 and then minus 4. So when you take negative out, this is gonna be negative also. So this is gonna be negative and then x plus square and this is going to be negative 6. So put this, it's going to be positive 6 and then minus x plus 2 and then square. So this is going to go inside this. So the integral, this is going to be dx and then you still have a square root 6 and then minus, just like I got here, minus x plus 2. So x plus 2 square by completing the square. So now this is already is a sign inverse. So sign inverse, you know, okay, if somebody gives sign inverse, for example, integral of okay, let's somebody give you integral of dx and then they give, let's say, a square minus fx square, which is similar to that. This same is say 1 over, and they differentiate whatever we have here, and they say arc sine fx over whatever is in here. So we're going to do the same thing here. So you say 1 over, when you differentiate this, you're going to get 1, and they say arc sine, okay, inverse, okay, fx, what is fx? Fx is x plus 2 over square root of 6, because this one did not, so we say square root of 6. So this is your final answer. You see what I'm saying? So now, another thing, if somebody give, for example, so you see it's done, quick, let me see if the same thing. Yes, it's the same thing. So now let's go to the next question. So this is how you do for most case. So you gotta go speed and accuracy and show your work clear, okay? Easy, man. Okay, cool. So now let's go to the next question. The next question, so we do the same strategy like I said, okay? Okay, let me just take the next question quick from the same paper. I can take from the same paper. Okay, same paper. Quick, okay, with you. Okay, yeah. Okay, I don't see the same thing from the same paper, so I can go to where I'm supposed to solve this question. Okay, let me get a question here. See, okay. So we have okay, sinh. So there's an integral. And then sinh of x, and then we have 1 plus cos of x, 1 plus cos of x dx. So this is a normal integration by substitution. Why? Because look, if you differentiate sinh, you're going to get cos. Look, so I'm going to let u equal to 1 plus cos of x. When you differentiate this, you're going to get du. When you differentiate this, it's going to give you sin, which is of x dx, which is going to come here. So now du means, instead of this, a du, so integral du, and then 1 plus sinh of x equal to u. So this, you know, is a ln of whatever u plus c. So ln, but I will know the value for u. What is u? 1 plus cos of x, 1 plus cos of x plus constant, because we don't have a limit. So for that case, now we have a limit of 1 plus cos x plus c, and the question is finished. So that should do 81. So it's almost the same approach. So I'm going to know this equal to, this going to be the part. So integral of tan inverse dx. So I know this is going to be by part, this is going to be u, and this is going to be dv. Okay. So this u and this dv. Okay, now let u equal to tan inverse of, look, I'm going to do a shortcut. This is going to be du equal to, differential is going to give you 6, and then this is going to be 1 plus 6x squared dx. Now, integrate that one, it's going to be dv equal dx. V equal to x. Now let's substitute uv. What is the u? This and this. X tan inverse of 6x minus. Okay, now v, x, okay, multiplied by 6. 6 is going to go to the back, and then right here plus 6x squared dx. So this is like 6x squared. It's like 6x squared. Now, x tan inverse of 6x minus 6. You see this one? I know if I differentiate 6x, I get x. Like 6x squared, look at 36x squared. If I differentiate this, I'm going to get x. Means if I differentiate this, it's going to give me that one. So it's going to be, so it's like 36x squared. When you differentiate, it's going to give us 72. And they say ln, write exactly what you have here, plus 36x squared. Down. And then you plus your constant, we're done. Okay, now let's go for the next one. 82. Okay, 82. So this is cos. So for cos face, okay, now we do the same strategy. Okay, let me just make a space here. Okay, cool. Now we go to question number 82. 82. Okay, so question number 2, integral cos dx. Cos dx. So we say now cos dx. Now let's go. So we do the same strategy, but if we put x is 9, oh, x squared, thank you. I don't like when it's x. X alone is easy. They should not give you only x, they must give you something. Okay, now let's say differentiate that one. Let's put here 2. Okay, and make it big a little. Let's say 3x squared, let's say dx. So it's also by parts. If you have any trigonometric inverse here, means by part. So say, so I know this is going to be part integral of u dv equal to uv minus v du. Okay, now let u equal to this one, cos inverse of 3x squared. Okay, let's differentiate du. Okay, equal to, differentiate what you have here. It's going to give us 6x right on top. But for cos, it's like this. So for cos, you always say, it's cos, right? Okay, it's cos. Okay, so for cos, okay, let me show you here. When you differentiate, add cos of fx. So this is what you got. It's cos, right? Cos. This is what you got. Differentiate your function, and then say 1 minus your function square. No. Function square minus 1 square. Minus 1 or 1 square. So I'm going to do the same thing here. Differentiate and then write your function square. What is your function square? This one here. In this square, say 3x square and then square minus 1 dx. Cos. Okay, cool. Let's go. So for that case now, and then when you integrate now, dx equal to dv, dx equal to dv, integrate x equal to v. Okay, now integral of everything they give to us, which is this equal to this, equal u times v. U times v, you start to the x equal to x, and then equal to times cos inverse of 3x squared minus integral v. Here we go. Oh, this is going to be a long question. So what we're going to do, I'm going to have to remove, it's going to be a very long question. Let's just put 3x. Sorry, let's just put 3x, is fine. So it's going to be 3x. For a reason, I know why I tell you that. We're not going to finish it today. Okay, let's make 3x. Okay? Now, so it's going to be 3x. Yeah, let's make 3x. 3x make a lot of sense. Otherwise, it's going to be very, very long. Okay, integral of, okay, now let's go. V, what is that? V equal to x? And then du, what is that du? Du, okay, this is going to be just, if you differentiate 3x, you get 3. So it's 3 now. It's no more like how it was. Okay, so it's going to be 3. So this 3, I'll take it back and then write this one. So it's going to be, okay? Okay. That's going to be 3x squared minus 1 dx. So this one here is a substitution. Substitution, right? So substitution, I can let, okay, this is 9x squared, so like a 9, let u, because here we find only here, let u equal to 9x squared minus 1. This du equal to, come here, this could be 18x minus 18x dx. So x dx equal to du over 18. Okay, so this is going to become integral only that, this stuff here. Okay, 3 x dx equal to du over 18. So 1 over 18 go to the back, and this is going to be du over square root of u. This, because this is u. Because 9x squared equal to square root of u. So it's like u a half. Take to the top, u a half is going to be u negative a half. Okay, so now let's integrate this negative a half. Let's integrate. When you integrate, means you add 1. It's going to be 1 over 18. Okay, negative half plus 1 equal to half positive, which is like square root of, and then divide by a half again. This is going to be 9. So this is the denominator is going to become 9. Okay, so but we know u, so this is going to be 1 over 9. We know the value of u. What is the u? U equal to 9x squared minus 1. 9x squared, so 9x squared minus 1. Okay. So all this stuff, when you integrate these, we get 9x. Okay, so I can replace that one. So I'll replace this. with okay, say integral of 9 x squared minus 1 over 9. Okay, by 3, 1 by 3, 3. So now this is going to be x cos minus, okay, 9x minus 1 over 3 plus constants over 3 plus 1. Now we go to the question number 83. Is also by parts as far as I see, but it's tricky also because you need to know all those forms, okay, of integral inverse of trigonometry. Okay, now question 83. Integral arc chord. Arc chord is like chord. It's like chord inverse of e 2x dx. So what we're going to do first, we need to, okay, this is by parts. This is going to be u and this is going to be dv. How do you know by parts? Because it's trig inverse, easy. So what I'm going to do, do I really want to put it like that? I feel like it's going to be big. Okay, let's put small number here. Call this, let me see. Let's put 2x for a reason I know. The thing is, okay, you might get double by pass and then another by pass and then double by pass and then we might not finish now. See what I'm saying? But let me go. But I know you might get double. Cool. U equal to that one. So let u equal to cot inverse of e 2x. Differentiate du equal to, when you differentiate this, you have to derive whatever you have here. So you're going to give it e 2x. And then, okay, for cot, okay, this is what you do for cot. When you derivate cot inverse of a function, it become derivative your function, but here must be minus, and then it's going to be 1 plus f of x squared. This is for cot. So I'm going to say derivative, you got that, and they say 1 plus square of the function. So function, hey man, let's just put this just on the x. You see, that's what say, better put like small number. This is, let's say x. So this is going to be just ex, same thing. When you differentiate x, you get es. 1 plus, and this is going to become ex or square. So it's like es 2x dx. Okay, this is going to be big. Okay, cool, let's go. And then, okay, now, and then we integrate this one. It's going to be v equal to x. We integrate dv equal to dx, v equal to, okay, now, u times v. It's going to be x times cot inverse of ex minus v x times, you see, that's what we're saying, times du. It's going to be e x, and then we got 1 plus e. Yeah, that's why I say, well, I shouldn't take a bigger number for a reason or not, because this is very big. This is not a work itself. So what I'm saying? So you can just take small number. The important things that I think you know, you just need to know this one. That's all. But when they give an exam or whatever, they don't want to give something bigger, like you gotta give again, you have to integrate again, integrate, no one to give again. You know what I'm saying? So yeah. So the problem is here. And you don't want to waste a lot of time in the exam. Now let's go to the next one. So you can take any number, let's say 2x. For example, let's say, okay, integral of cot, let's say inverse of, say 2x dx. So I'm going to say, okay, uv, okay, u equal to cot inverse of 2x du equal to, differentiation is going to give you 2 over 1, but it must be minus here. For cot, it must be minus. For tan, no minus. You plus square, this is going to give you 4x squared dx. Okay, when you integrate this, because dv must be equal to dx, so v equal to x. So put in the formula uv. So say u, all of this equal to uv. What is that u? U equal to that one times vx. X times cot negative 2x minus integral v. What is a v? V equal to x, and then negative 2 is going to come to the back, and it's going to be positive 2, and this is going to give us 1 plus 4x squared. You see now it's easy, because this is long, we know. And then this is going to write the same thing here, and then we plus 2. This, excuse me, we know if I differentiate this is going to give me x equal to x. So what I'm going to do, I'll just say 1 over, it's like 2 over 8x. Just 8, not 8x. It's 8. And there's a ln of this denominator. 1 plus 4x squared plus constant. You see, that's how they're going to give to you. Not like the first one. Okay, now we go to question number 84. Question number 84, you say integral arcsine 3x dx. So just like the same, but for sine now, we say, okay, this is going to be our u and the dv equal dx. Okay, let u equal to arcsine or sine inverse, in other you can say 3x. Okay, let's differentiate d, u equal to differentiate whatever here, you can give 3. But for sine, this is what you do, say 1 minus square of a function, which is going to give us 9x squared. So this, and then this 3x. That's how you do for sine. Differentiate right at the top and the 1 minus square of a function. You see what I'm saying? Now, dv equal dx. V equal to x. Plug it in the formula because it's by part uv. U times v. X times sine inverse of 3x minus integral vx times du. 3 is going to go to the back. 1 minus 9x squared dx. Okay, so this you can do substitution. So here is okay, so we want to come here, so it's going to be the same thing, minus 3. So let's see, this is equal to u, so it's going to be u square root, and this is going to be du. Man, I think one of it. Okay, this is so let, okay, I'll just keep this pending, right? Let u equal to 1 minus 9x squared. Okay, du equal to negative 18 x squared. So divided by negative 18 divided by negative 10. So this is going to be du over negative 18. So means here is going to be negative 18. You see what I'm saying? And then this is the u over negative 18. And then this is going to be square root of u. Yes. So now we're going to have, okay, when you end it, it's going to be, okay. This is going to be negative 3 square root of u. You can do slowly. And this is going to be 18 over 1 over 2. This is going to give us 9. Okay, 1 over 3, negative 1 over 3 u. I'm gonna make mistake here. I think I'm doing it right, but just in case of, let me make sure. Okay, so I'm gonna say, take to the top, it's gonna be u negative a half plus 1, same thing, and this is gonna be half. It's gonna be square root of u. I was right. Square root of u, square root of u, and it's gonna be 2 a half. Yeah, true. So a half, because we integrate. Okay, let's go. So let's take to the top. It's going to be u a half, and then over 18 times that is going to be equal to 9. 9 and 1 over 3. Okay, you can do slowly. Do you really want me to do like slow, like a baby or something? Because now you know what is happening. Okay, let's go slowly. So you understand? Okay, so this is going to be a half, and this is going to be a half 2, and this is going to be 18, and this is going to be 9, but we still have 3. This is going to be 1 over 3. 1 over 3. This minus or plus. Oh, so it's going to make it plus. Yes, it's going to make it plus. Because it will take to the top, it's going to be u in there. It's plus or minus? Come on now, always a little time I'm made. Where did this 18 come from? Okay, let u equal to this. So it's going to be u, and this is going to be, okay, u equal to that one, 1 minus 9x squared. Yeah, it's negative, yeah, so it's going to make it plus, it's true. And this is going to be 1 over 3, and this is going to be square root of u. Yeah, it's true. Okay, so raise all this stuff here. Okay, but I will know the value of u. What is u? 1 minus 9x squared. 1 minus 9x squared. Plus constant, because we don't have no limit. So this is going to be x sine. Done. The plus 9x squared plus c. Now we go to the question number 85. So like I said, when you finish this, we 8 because we start with the 8 question number 88. Okay, let's go. Okay, cool. Now let's go. So integral of t sec square 2t dt. So this also by part. So this is going to be dv, and this is going to be v u. Like I said, do a lot of in this form. If you have a t or x and then trig, and then this is going to be u and this is dv. Okay, let u equal to t, so du equal to dt. Okay, we integrate now because dv equal to sec square 2t dt. Now integrate v equal to, when you integrate this, is going to get 1 over differentiate whatever you have there, you're going to give it 2. Now when you integrate sec square, you get tan. So you get tan what? Tan 2t. Now let's substitute in the formula. Formula we know is going to be all of this equal to uv integral v du. Okay, uv t times that, t times this is going to be over 2 tan 2t minus v. That's our v, a half whatever. So I'll put my half out, multiply by that. It's going to be, okay, it's going to be tan 2t, and then multiply du. What is it, du? dt. And then it's finished now. So t over 2 tan of 2t minus a half. Differentiate this is going to give you 2. 2 times equal to 4. Okay, now when you integrate tan, you get sec square. So it's going to be sec square 2t. So 1 times anything, just 1. Sec square t plus c. Okay, so you can say all this divided by 4. Okay, done. Now let's go to question number 89 now, because we finished this. Question number 89. Okay, 89, integral 2, 3, 1, and there you go, x squared minus 1 dx, 90. Okay, integral x minus 1, x cubed, x squared, plus 3x, plus 2, dx, 91. Integral tan 3x dx, 92. Let's put here 92. Integral of x cubed plus 4 x squared plus 4 dx, 93. Integral of a x squared dx, 94. Integral of 1 over y plus 2, y plus 3. This, yeah, dy. 95. Okay, let's continue here because of the space there. 95 cos 15x cos 4x dx, 96. Integral of sec 9x tan x dx, 97. Integral of tan x, 98. Integral of dp. Number 99. You must be laughing when you see that. Okay, and then okay, there's another one. Integral sec 4x 10 power x, and then x dx, 100. Integral sec square 5x dx, 101 integral cot 3x dx, 101 and 2 integral of tan 4x cubed dx, 102 integral 0 to 1 tan inverse of 7x dx, 102 integral arc sine 5x dx. Okay, it's 103 integral, use other pen quick, integral 1 over 49 plus 16 x squared, and this is square root dx, 104. I'll start, don't worry about it, the space can be enough. I know how I'm going to handle this. Integral, okay, 1 9 plus 25x dx, 105 integral 1 9 plus 6x squared dx. Okay, I think we stop there. Yeah, cool. 105. Let's go. So for now, let's stop this. Let me see if it record. Does it record? Yeah, it does record. Cool. Let's go. So first and foremost, let me start here. So if I finish all this stuff, means I'm done with the 105 question. Let me see here. Let me write here. Let me write here. 105. It's gonna be done. Okay. Let me start with this one right here, and then I'll finish all of them. Okay. So this let me say, whenever you have a square root and then there's a plus here, this meaning you can solve in two ways. A, they can be hyperbolic, or it could be tricky. So in exam they might tell you, oh, anywhere solve is hyperbolic because it's root. It looks like a tan, but it is a plus. So I have to write as a root, as a square root. How am I going to do the log? 6 is like square root of 6 x square log. When you square root 6, square root of 6 times square is going to get you 6 alone. X square is, so I'll rewrite this. I'm going to say, let me rewrite, it's going to be square root of 6x. So this, let me say, integral of 3 square plus square root of 6x, and then both of them square dx. And then I'll say, and then I'm going to say dx. Okay. Okay, so this let me say, now let me start with a hyperbolic. For hyperbolic, this is excuse me, this is square root. This is sinh. So say 1 over derivative function. When you derivate this, it's going to give you square root of 6 alone. Means square root of 6x. When you derivate this alone, it's going to give you square root of 6. And then say sinh inverse, or you can say arc sinh. Sinh, arc sinh is the same thing. Take your function which you have here, which is square root of 6, and x over a number which is here, which is 3. You plus constant. So this is for hyperbolic. But the same question I could write as a trigonometry. So for trigonometry, only is in this format. There's a different format. There's sinh, cos, tan, sin, cos, all of them. Okay, now we go. So for trig, it's supposed to be like this. So 1 over derivative function. When you derivate, you get square root of 6. And then say ln. So I don't need this 1 times anything, just 1. Ln, and then I'm going to write my absolute. Take your function exactly right here. And then you're going to plus exactly what you have here. The one that gave to you, is better to take the one that gave to you. Put here. Even if you put this on, but I'd rather take that one. Square root. This could be 9 plus 6x squared. and then I plus my constant because there's no limit. I must put my absolute because there's a limit, there's a ln here. So we put my absolute. So we're done with that question. So we go to the top. So even question 104, we go for the same approach because there's a root and there's a plus. Okay, there's a root and plus, so this is going to become, okay, let me do for hyperbolic phase, it's going to be 1 over, this is going to be 5x squared, because you're on 5x, so it's like 5x squared. So it's like over 5, and then I say arc, sinh, and they'll say, put my function is going to be 5x because 5x squared, so it's like 5x over 3, because when you square this 3, when you square this, it's going to be 5x, and this is like a 3 squared plus, okay. And then plus your c because there's no limit. Or if I want to write as a trigonometric, I'm going to say 1 over derivative of 5x, which is going to give you 5, and then here write ln, so you can say all this is like 1 times ln absolute. Write your function, which is 5x plus exactly 9 plus 25x square, sometimes plus constant because there's no limit. Sometimes they write this 5 here under everything, and they can remove this. So it's optional. So we're done with that one. So even question 103, the same approach. Because there's a root and there's a plus. Okay, so how I'm going to do that one is easy. So, let me do this one, then come for this. Let me do this one. We got to go with the flow. Now, no, 3, 2, 3 phase. Okay, so I'm going to say this is 7 square plus 4x square, bracket square. So I'll say 1 over, in trigonometric, 1 over 4, because I derivate this on 4, and they say ln, so I can write ln, and they write everything one line throughout. Absolute 4x, plus exactly what they gave to me, 4, 9, plus 16x square, and then I got my root absolute plus constant. For hyperbolic, because it's root and plus, if it's minus, another story. You don't do like this, okay? So now we're gonna say, let's go. Okay, arc. So 1 over derivative function will give you 4. So arc sinh, and then 4x over a. What is that? A equals 7. And then plus our c. So we're done with the question. Go number 102. So I go back to back. Okay. 102, now we go. So 102, we're going to say, okay, now let's go. You ready, guys? 102. So this is, okay. So I'm going to say this equal to u and this dv. So u equal to arc sinh. So it's like arc sine of 5x. And then dv equal to dx. So when you differentiate this, will give you du equal to differentiate whatever function you have is going to give you 5. But for sine, it's going to be 1 minus your function square, which is 5x square equal to 25x square. Okay, when you integrate dv, you get v. When you integrate dx, you get x. Now, u times v, we know form, bypass u times v, because the formula says u dv equal to uv minus v du. Okay, uv, what is the u? U equal to this one times v. So x times arc sine, or you can say sine inverse. Sine inverse of 5x minus v. What is the v? V equal to x times du. This is our du. 5, I'll take 5 on the back, and then I'll say over, because I must take 5 on the back, it's going to be, this is over 1 minus 5x squared. That's called dx. So what I'm going to do, you can say 25, whatever you prefer. 5 or 25x squared. Okay, so I can just, okay. So I think I understand here. Okay, let me go. 1, this is going to be 5, and then this is going to be square root of u, if I let it equal to u, and then over 1 over 2, and this equal to negative 50. Yeah, I believe so. But you can do slowly, okay? The plus, but u we know. What is the value of u? U equal to 1 minus, you can do slowly. Tricky substitution. If you follow me from beginning, then you should be able to know how to do this. This and this, okay. This is going to be negative 10, okay. By 2, 1 by 2 is going to be 25. By 5, 1 by 5 is going to be 5. Negative, negative, positive. So 1 over 5. Yeah, 1 over 5. Positive 1 over 5. But you can do slowly and do substitution. Positive 1 over 5. So this is going to be 1 over 5 positive, and this is going to be x sinh 5x. Done. Plus constant because there's no limit. So all of that, you differentiate to get this answer. Okay, now we go to question number 102. Okay, cool. Now we go. That question right there. So that question could be the same. Okay, now we go. U equal to this because this gonna be by parts. U and this gonna be dv. I can do straight away now. Look. Let me do it ahead. Okay. Means okay. What is a U? This gonna be U. Okay. Let's differentiate. This gonna give us peace. Thanks a lot. Thanks, Melissa.
My queen, you gon' wait me till Jesus come. Why when I talk, pocket full floss, money, honey, forget about Suzanne.
So since we don't have all the equipment like cameras and all this stuff, so just use one of the webcam from my computer